So here we are looking at a stretch of Hyalite Creek, and we're going to use this stretch to talk about channel reach morphology. So what is channel reach morphology? Well, let's first define what a channel reach is, which is just a section of river like the one I'm filming that's exhibiting similar characteristics, meaning sediment size, bed load, and overall geographic location in the river. So this channel reach morphology, how did it form? We're going to call this one a cascade channel reach. Cascade channel reaches, well, they look like this. They're dominated by bed roughness. As you can see, we have boulders, we're going to have cobbles, and we're going to have finer sediment. And we're going to see that across latitude and longitude of this cascade channel reach. Cascades normally form in mountainous streams. They're characterized by a steep slope, by bed roughness, and they are definitely supply limited, meaning that the ability for this river to transport sediment is far above the actual sediment that is getting into this river. So now we're going to move on from the channel reach morphology being cascade, and we're going to talk about boundary shear stress, critical shear stress. So boundary shear stress is just force exhibited by water on a particular size sediment. Whatever we're seeing, it could be different across all areas of this stream. And then what we're talking about the importance of is the critical shear stress, which is the amount of force by water needed to transport X sediment. So as you can see, for this cobble, it's going to be huge, right? That's going to be there for decades. But for finer sediments, the critical shear stress is going to be lower, and those are going to be transported out, all right? And the critical shear stress for eroding hill slopes, a little bit more confusing because you got things like clay cohesion that's actually stronger and drives the critical shear stress up. So cascade reach, sediments being transported, overall theory is critical shear stress for that. All right.